Match the following question from electrochemistry. Column A and column B. The cell used in hearing aids. It is the mercury cell. Next is the cell used in Apollo space program. That you know is a fuel cell. The cell used in automobiles and inverters. That is the one which can be used again and again. That is the lead storage cell. Then the cell which does not have long life. And that is a dry cell, which is a disposable cell. Now let us just look at these different cells and their reactions. First is a mercury cell. It is used in low current devices, that is like hearing aids, watches, etc. Anode is given as zinc amalgam. Then cathode, a paste of HgO and carbon. Electrolyte is a paste of potassium hydroxide and zinc oxide. So this is the reaction at the anode, and the reaction at the cathode is this. The overall reaction can be represented like this. So mercury cell is a primary cell, and it is non-rechargeable and it is disposable. It cannot be reused. It is a disposable, and it is a primary cell. That is how we define a primary cell. It can be used only once. Next is a fuel cell. It was used to power the Apollo space program. So the cathode anode reactions are like this, and the overall reaction is this. You can see that the product obtained is water. So it is a comparatively pollution-free cell which can be used. So this fuel cell, what is a fuel cell? It is a type of galvanic cell. Galvanic cell is the one in which chemical energy is converted to electrical energy. So here, this is a specially designed galvanic cell, a fuel cell, to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy. And such cells are called fuel cells. And the next type of cell is a lead storage cell. It is used in automobiles and inverters. And this is a secondary cell. That is, this cell after use can be recharged by passing current through it in the opposite direction. Anode is this. It is lead, and cathode a grid of lead packed with lead oxide, PbO2. Electrolyte is 38% solution of sulfuric acid. Anode and cathode reactions can be given like this, and the overall reaction can be represented as this. So this is a secondary cell, and this can be used again and again, and it is mainly used in inverters and automobiles. Next is a dry cell or a Leclanché cell. So this is commonly used in clocks or transistors, etc. Again, a disposable cell, and it is a primary cell. So in this type of battery, the reaction occurs only once, and after use over a period of time, the battery becomes dead and it cannot be used. So here, anode is a zinc container and cathode is carbon or graphite rod surrounded by powdered MnO2 and carbon. And this is the anode and cathode reactions given. This is a nickel cadmium cell. Again, this is a secondary cell which can be reused. The overall reaction is represented like this. So a secondary cell which has longer life than lead storage cell. So that is the nickel cadmium cell. Now one question about a previous year question, a give reason question. Why does a mercury cell give a constant voltage during its life? So the cell potential of a mercury cell is approximately 1.35 volt. Now the overall reaction of this cell does not involve any ion in solution. If there are such ions in solution, their concentrations can change, and as a result the output or the voltage can vary or the potential can vary. So here the overall reaction does not involve any ion in solution whose concentration can change during its lifetime. So that is why throughout its life it is giving a constant voltage.